Hello and welcome to Extreme Academy Live. This is where you come to advance your knowledge, advance your skills, and advance your future. Thanks for advancing with us. Thanks for advancing with us here at Extreme Academy. We're in the final episode. We did hint that we could get this course landed within 7 episodes, within 7 weeks, rather than the 8 that we publicised, and that's what's happened. Isaac and the team have been able to consolidate down, and we're gonna finish today. So this is the final episode of this course. Now, because of that, we've crammed in a lot, so I won't hang around. Isaac's going to do his normal thing and the teaching. Then Claire's going to come in towards the end. She's going to tell you about how to access the certification exam, the all-important certification exam, because when you pass that, you get the badge. And that's your proof to your future or current employer that you understand this topic. You understand what it takes to build these big networks that the world needs. And you've gained knowledge, you've gained an understanding about what it takes to design, manage, and run this kind of infrastructure. All right, so straight on to Isaac. Isaac, you ready to go? He's ready. I'm going to go in the chat, so I'll be there to chat in the YouTube chat window if you've got any questions, and I'll see you at the end. I'm going to come back at the end just to close out today's episode. Over to you, Isaac.
Thanks so much, Rowan, for always doing the introductions and always being really kind. It's fantastic to be back. This really is the last episode, right? We thought we might do 8. I think I said at a point in time that we might not get there, but we've timed it so this will be the end of the 4th course. So there's quite a lot of stuff to cover today, some more interesting stuff. Once again, just thank you to David Stuck for the last 2 weeks, for being my guest on the last 2 weeks, and for opening up his house to be able to record there. I thought that it was a fantastic session to have with David, where he opened up, fabric and what fabric is all about in an understandable and really clear way. So David, thank you so much. Also, thank you to Claire, Rowan, and Bethany for being involved with Academy and just making all of these things work. I mean, there's so many moving parts, and they're just great at making this work. You see my face here a lot and Rowan's, but there's lots of people behind, behind this that make all of this possible. So to all of you and the team that does video editing for us and all of those stuff, thank you very much as well. So without further ado, let's get into the content. We've been covering large resilient networks. We've covered a lot of stuff already, and a lot of new terminology popped up in this course. I read some of the comments on YouTube, and generally it seems that the more technical people have really enjoyed this course, and that's understandable. Not often do we get to work on really big systems. To be honest with you, I haven't had that opportunity yet to work on massive systems with 5,000 users or something like that on a large network. I've never had that privilege. I've never had that opportunity. I used to work with smaller networks, but the principles apply. Of course, now as you grow bigger and start managing really large networks, that way you start to understand a lot of the stuff like fabric and OSPF and BGP and all of those particular protocols. But I think we've covered a lot of stuff, and I really hope that you guys have found this course helpful. For those of you who haven't, who are just tuning in and watching this episode or don't know much, remember, you can go onto the Extreme Networks YouTube channel, and on there's another 3 courses that we've already done, foundational, which teach you the very basics of networking. We did a course on wireless, which is very popular and people keep watching it all the time, and they did another one on careers, on getting yourself a career in the technology industry. So there's a lot of stuff. Now, networking, we've spoken about building these networks and what it takes and how you think, for the philosophical approach to all of these. But you cannot be a comprehensive, a brilliant network engineer, you can't achieve that without what we're talking about now, which is having a set of management tools, right? The ability to manage large networks. That's very, very important. And I've got a. You're gonna see me looking, down. I bought myself a new iPad, so I've got it here on the side of me. So occasionally you'll see me looking down or just writing on the screen. The management tools, we're going to be breaking them really into two main categories, and that is on-prem for managing of on-prem devices, on-prem management tools to manage on-prem devices. I think that's kind of explains it. And the other one, of course, is what is becoming hugely popular and the standard way of doing this as we go forward, which is managing networks in the cloud. So in the first, I think it was the first episode that we did of this course 4, we did this slide. We've already done this slide, and this slide was essentially talking about the 3 different planes that you get when you're talking about network. When you're thinking about networks, we talk about them as 3 different planes, 3 different layers. If this was Photoshop, you can think of them as 3 different layers, okay? Really important, each layer doing a specific job. And we had down the bottom, we had the data plane. This is where you and I interact with the network, right? The data, the bits and bytes that are flowing through. So you get the data plane, you then get the control plane, okay, the control plane, the operating system of the devices, where the devices discover environment and things like that. And then this is what we're going to be talking about this module now, which is the management plane. The management plane. Now, it's a application, generally a software application, and its job really is on managing devices or the network, or in this case, the networks that are made up of all sorts of devices, be they routers, layer 2, layer 3 switches, be they access points, be they whatever it is, core switches that carry a lot of traffic. This is where on the management plane you're going to have different levels of permissions, different levels of authorizations, and you're going to get the team that's going to be there. They have read-only access and they can kind of monitor what's going on, right? And then you're going to have a higher level, maybe an admin level, and they have the ability to do things like create policy. What is creation of policy? Well, it's policy that's going to apply, that you have come into an agreement, either the IT team or a combination of the IT team and management, whatever it might be, but you have decided that we're going to push a policy down to, let's say, our access points. And we're going to say our access points are, we have a retail business, a restaurant business, so at midnight we close our businesses down and we're going to, kill our access points up until 6 o'clock in the morning or whatever it is. So you could have a policy that says at that point in time, shut down the access points if it was possible to do, but you get the point. Something else could be if you have an access point and it has, say, 2 different radios, say a 2.4 and a 5 gigahertz, you might decide, what, we just want to carry 5 gigahertz traffic. All our devices, all our point of sales, they're all 5 gigahertz. So we're going to switch off the 2.4 and we're going to convert that, or we're going to switch it over to a 5 gigahertz radio. So that could be a policy that somebody as an administrator would push down to the access points. And when that access point is plugged into a network and it's alive, the policy is applied to it and it behaves in that way. Right? Optimize, fine-tune, troubleshooting. This would be done on the management plane. Another really important tool or function that works on the management plane is analytics and reports. Now, in Extreme Networks, we use Extreme Cloud IQ as a cloud managed solution. Now we have on-prem as well, but let's just talk about the cloud managed solution. One of the really important things about that is all the data points that you get back from your network. They give you information, and to that you have intelligence, right? Now, those are really important because those help you to plan. Do you have enough access points? Are your users constantly complaining that the network speed is really low? Do you have a situation where you have 200 people in an office, and you have one access point for all of them? Those are the type of things that analytics is going to be able to tell you. Analytics is going to be able to look at your entire network and, using AI, for example, look at the anomalies and say, that's problematic, because that, compared to all the other stuff that I measure, that doesn't feel right, that doesn't smell right, that doesn't sound right, there's something wrong over there. So all of this happens on the management plane. Now, management plane is also something that's going to help you as an IT person interact with the CFO, with the financial people. Because when they come to the end of the year and they say something like, hey, we need to plan for next year's budget. How much do we need to put into the budget? You don't have to go, let's put $500,000 in. You can look at the stats, you can look at your network growth, the amount of traffic. You can see from that data how much you need to budget, right? The type of growth that the company is experiencing. And so you go from, I think, to this is what we need because this is what the data tells us. Management plane. Now, let's talk firstly in this first part about on-prem, and then we'll talk a little bit more about cloud. So Extreme Academy was built on the concept that we are network agnostic, right? We don't talk about our products and try and sell our products. This is not Extreme Academy is a sales-free environment. So we're not here to sell. But I'm also not going to sit here and talk about our competitors' products, right? I'm going to talk about our products, and management of networks is part of the things that we do and part of the business that we do. And we have very good tools. And one of those is something called Extreme Management Center, which is a unified WAN and LAN, right? Wireless LAN and LAN network management system, NMS, right? That manages wireless systems, that manages wired network devices, and simplifies the users simple tools. A system that simplifies tools and automates the management of your network. So you'll see if you go to Extreme Networks website, it's sometimes you'll often see it as XMC, Extreme Management Center. It's a single pane of glass, like Extreme Cloud IQ. It's a single pane of glass, one window that you can go to that can give you all of this information that you're looking for, that is important in managing a network. It's a collection. It's really made up of a collection of software tools. So think of it as it is a software platform running inside a software application, and then there are specific sub-functions of that, sub-tools within that, to be able to provide all the intelligence that you need. Things like monitoring, health status, visibility, control of devices. Here's a better slide of what XMC does, Extreme Management Center does. If you look at that, take a screenshot. If you've got a couple of seconds, just take a screenshot, because these are kind of the applications that you have within XMC to do everything that you need to do. And one of the most important is, if you have a license with the NMS Network Management System Advantage license for this XMC, one of the things that it allows you to do is it allows you to configure, connect, set up a fabric infrastructure, like we learned in the last two lessons. You can manage that whole fabric infrastructure using templated systems that you have on here, and then you configure them to exactly how you want that fabric to work and to be deployed on your particular network. So it's an incredibly powerful tool with a number of different sub software sections, if you want to call it that, that allows you to just do this whole thing end to end. So very informative, and you can go and read more about that on the Extreme website. Now, this is not an unusual application. The architecture of XMC is not unusual in this industry, because it really has three main aspects, right? Number one, you have a central database, which you can see, over here, the central database, and central database. I'm just trying to get this thing to draw, and it doesn't seem to want to draw. So let's see if we can do that there, the central database. And when we go to a break, I'll see if I can come back to this and get this thing working. Let's try once more. Okay, I can't get that to work. What can I do? Right, so we have a central database where you do things like device groups, profiles, topology. You have a server that accesses the database. So, of course, you separate those two from each other. You don't put everything on one application. You separate the server. And then, of course, you have the clients that connect into the server, and they use an SSL HTTPS connection. Okay, so this is not unusual, and in essence, this is what it looks like. This is what it looks like more. You have your clients coming into the MySQL server, and that MySQL server is then going to query the actual database. So that's pretty standard within this industry. Now, that is what we use at Extreme for network management systems on-prem. What other companies use, I don't really know. I don't have enough experience to tell me, but I'm pretty sure if I asked you the question, you guys, there would be tons of answers on this YouTube chat over here, because everybody, has different mixtures and of equipment, etc. on a network, and you need to monitor all of that information. So why is cloud so popular? Why do companies like Extreme, for example, why is Extreme Cloud IQ so popular? Let's talk about this as six reasons, the 6 S's, right? The 6 S's as to why cloud is so popular. The first one is simplicity. From provisioning to support to data intelligence, all of this stuff is made effortless, simple when it goes into a cloud. Now, that doesn't mean that just because a vendor puts a solution in a cloud, that all of a sudden that is, that it's simple, right? It doesn't mean that, because I've seen solutions in the cloud that are not simple or complicated completely. In Extreme's case, we've done a really good job. We've done a job on the GUI. We constantly updating that to try and make things simple, to try and make things really easy. And it's great, right? You don't have to worry about servers. You don't have to worry about patches and updates. It's simple. What about speed? Speed is another one of those reasons, right? The ability to roll out software, the ability to roll out features, the ability to fix bugs. If you have to just fix or roll out a feature and you put it into a cloud, it means that every customer, you got tens of thousands of customers, instantly they have that latest feature. Think about something like Office 365. How powerful is it for Microsoft to roll out an update and millions, tens of millions of Office 365 users instantly have those updates? It's absolutely fantastic to have. Now, if you think about that, in years gone by, 10, 15, 20 years ago, I used to love software, and I used to do reviews of software, sometimes for newspapers and stuff. And when Microsoft released a new version of Office, someone had to go and chop down trees, cut down trees in the forest and chuck that into a mill, roll it, make paper, and then print books this thick, with 20, floppy disks inside boxes, put those boxes in other boxes, put them on shipping containers and ship them around the world. And we would get these big 3-4 kilogram books, with tons of stuff on it just to tell us about updated features. It's so much more simple now. So the speed of this is much more simple, right? Google decides to add a feature into Gmail, they can do it like this. They don't have to worry about every type of computer and every type of operating system and every type of device. They just put it in a browser. It works. So speed of execution, speed of getting this out. This is so important to companies. Service, right? With APIs, you have already a GUI within these cloud solutions, but very often these cloud solutions, not just Extreme, just even Gmail, all of those, they provide open APIs. If you don't know what that means, it's application programming interface. It's like a set of tools that allows you to adjust and to query and to extract data from a system like Extreme Cloud IQ or like other systems, and then use that API to then create other applications that sit on top of that, right? It's fantastic. The services that they offer you within a cloud solution often makes it very, very important for a customer when they make a decision as to what system they're going to be using. The next one is scale. Now we know about this because scale is so important. Scale is the ability for us. Let's see if we can get. Nope. Scale is the ability for us to be able to scale up or scale down on demand. And that again is an incredibly powerful option for us, because when we need the hardware, it's there, and when we don't, we don't have to pay for that. The traditional model of all of this is, we need to buy servers and have them on premises, and there's nothing wrong with this. There's still plenty of reasons why you would want to have infrastructure on your premises, but just think about that. You have these incredibly powerful servers, and for 5 minutes a day they've been used at 40% of their capacity. The rest of the day they're sitting there with their arms folded doing nothing. But you've paid for that, or you are paying for that. Whereas in the cloud, when you need that capacity, you can scale up, and when you don't, you can scale down. So this is another reason why companies really like it. And infinite scalability with Extreme Cloud IQ. We've got something like over 1.5 million devices currently connected into the cloud, being monitored by and managed by Extreme Cloud IQ. 1.5 million. So what? If you build it correctly, if you build it with containers, it could be 2 million, 3 million, 5 million. And hopefully one day we will have 10 million devices being managed under Extreme Cloud IQ. Infinite scalability. Security is another big concern, and certainly used to be a massive concern in the past, but it's still a concern. And we did address this. I have addressed the security of this as well in cloud previously. For businesses like the big cloud players, for them to get our business, for them to get company business, enterprise business, for them to get government business, they have to meet all sorts of security certifications, both physical, both logical, the way they set up their infrastructure. So you have this massive layer of security that is applied by the cloud vendors themselves, and they get audited because that is so important to their business. On top of that, you then get another layer which is written into a system when it's designed. So Extreme Cloud IQ has these various certifications. One of them is ISO 27001. We were the first in this industry to get that certification. Not to say, oh, we're in operating from a 27001 data center. No. For the company to actually get a ISO 27001, we were the first in this industry to get that. But we didn't stop there. There's other ones as well. There's another 2 ISO certifications that we've attained in this year. And I think we've just attained SOC compliance as well, which is absolutely fantastic. So security is an important consideration. And then the last consideration, the last of the S's, is saving money, right? You no longer have to spend capex buying hardware to run, systems that are only going to be used for a short period of time. It's not going to happen anymore. From now on, you have it's an operating expense. It's no longer a capital expense, a capital outlay. So it just makes a lot of financial sense. So these are the main reasons, 6 reasons, if you want to call it, why people move to the cloud and why Extreme Cloud IQ. Those who don't know, Extreme Cloud IQ came from an acquisition from a company called Aerohive. It was mostly a wireless management system, but when Extreme bought it over, they brought in their vision, which was to make this an end-to-end network management system. So you're doing access points, wireless, layer 2, layer 3 switches, routers, everything being able to be monitored by one system in the cloud. So we wanted to be device agnostic. And nowadays, we have tools within Extreme Networks called Extreme Cloud IQ SE Site Edition, where we can then start monitoring any device, totally agnostic. It doesn't have to be an Extreme device. It could be from one of the other vendors. And that can be monitored from within Extreme Cloud IQ Site Engine. And then the next level will be to take that up and connect it into Extreme Cloud IQ. So you could get cloud visibility of your entire network, even if it is not Extreme devices. That is incredibly powerful. The next layer up, of course, is deployment agnostic. Not every customer wants to move to the cloud. There are many valid reasons why some customers do not want to go to the cloud, or certainly are not in the process right now of moving to the cloud. That might happen. It could be security, it could be government. There are many reasons why that is the case. But Extreme Cloud IQ as a cloud solution offers, number one, the ability to have public cloud, right? And that's the cloud that we know when we talk about Amazon and Azure and Google, the public cloud. The next one that we talk about is when we talk about private cloud, companies that have their own, are big enough and they have their own private cloud. Well, those companies, if they want a cloud solution like Extreme Cloud IQ, we can put that into a private cloud. And then there are companies that have, on-premise, they want that, but on their own premises, they can get that as well. And that's not all. The next thing about our cloud solution is that it's not limited to our cloud. We don't say our solution runs on Amazon's cloud. Now, again, I have to talk about this, not trying to sell you anything. I'm just talking about why cloud is popular and how it relates to what we do. But our solution runs on Amazon cloud. Just because of the way that it's architected, you can lift that up and put it onto Azure cloud, and you can lift that up and spin it up in a Google cloud, right? We are cloud agnostic, and that is the gold standard, right? You want to build the architecture in a containerized manner where you can just take the code, put it into another data center, spin it up, and away you go. Right? That's what you want to do. We have customers, for example, in the retail business, and they say, no. Amazon already takes too much money from us. We don't want to give them more by doing this in the cloud. Your solution is great, but it's in the cloud. It's Amazon's cloud. So what? We can spin it up for you in the Microsoft Azure cloud, or if you want, in the Google cloud. That's why customers are buying Extreme Cloud IQ. That's why the solution is so powerful. Data privacy, we've spoken about this, ISO certifications. Go onto the Extreme website, go and look up certifications, security certifications, and you'll get a whole list of things. Things like GDPR. Any cloud solution has to be GDPR compliant, right? We've spoken about that as well in the previous courses, so I'm not going to focus on that. But you get the idea over here. Management, on-prem, cloud, these are the benefits, these are the options, this is what you can do. You can start off on-prem and then move to cloud. There's a lot of options that you have. I'll see you after this 1.5 minute break. Get up, stretch, just take a quick, if you need a glass of water or something, go do it. We'll be back here in about 1.5 minutes. Cheers. Okay, let's move on to the next part today, where we're going to be talking about mobility and distributed environments. And what we're talking about here is going to be mobility at the edge. What actually happens? All of the stuff that we've been talking about, these networks, resilient, scalable, secure, all of this stuff that we've built. What is it for ultimately? What is it for? We're going to talk a little bit about Wi-Fi best practices, and that should give you a clue what we're going to be covering over here, and then extending services to remote users. So let's move into this. Everything that we do in our network is ultimately for the most important stakeholder, right? Which is a user. If you think about businesses say, yeah, well, we're a bank, we're an online bank. That's what we do. And our infrastructure is all about, providing good banking. Ultimately, all of that you do is to provide a service that is great, that's fantastic to a user, your client, who trusts their money with you, who trusts that when they make a transaction, that transaction is accurately recorded, that it gets accurately reflected in the bank statement when I go and look online 30 seconds later, right? It's about the user. When you have a Facebook, a Meta, for example, what is the most important stakeholder? It's the user. Right? So many social, media applications. What is their target? It's the user. The user is the most important. We've had Snapchat, I think it was a while ago, change the interface. They should have had a wider range maybe of testers, because the users were not happy, said, no, this is not great. And they had to change back to the older interface, right? These things are important. Why is that important? Because you could lose hundreds of thousands of customers overnight, over 2-3 days of non-service, and you can lose those customers and lose that business just like that. So ultimately, the user, the end user, is the most important stakeholder in a business. And what does a end user want? An end user needs access. Now you might think that's really strange. They need access, but you need access to what? Well, you need access to data. If you sign up with a new mobile phone, you need access to the internet, right? That's what you need. You need access. And once you've got that access to the internet, you need access to your data. And that could be your Instagram, it could be your Facebook, it could be your Messenger, it could be your bank statements, your bank accounts, it could be, your collection of photographs online, it could be your learning schedule, your university schedule, it could be 1,000 different things. It's in your data. That's where it is. And how do you access the data? Well, you access the data using apps. We used to call them software programs before. Nowadays, when it went mobile, we started to change the name and we call them apps, applications. But users want access to a network. What does that give them? It gives them data. And how do they access that data? They gets it through apps. I used to think, when I lived in South Africa, Americans are crazy. Do you know that they have, weather channels, not just one, like various 24-hour weather channels, in America. And I was like, I never understood it when I was a teenager living in South Africa. It's like, why do you need a 24-hour weather channel, right? Actually, it's not just about whether it's going to rain today or not. That is data. Those farmers, not just farmers, think about rescue, think about tornadoes, all of those. They need to have access to those predictions, weather predictions, to be either being able to sow seed at the right time, at the right point in the season, or in the case of tornadoes and hurricanes and disaster weather, to be ready for what's going, to be able to evacuate people. It's not just weather. Behind the weather is data. That's what people want. So Americans, I now understand. I moved to the UK and I understand now when you can have 4 seasons in a day, but mostly it's just rain, rain and cloudy in a day. I understand. Now you have these 3 data points over here, and then you have a management of those, a management of access, which is things like security, for example, a management of data, which is, making sure that the data is correct, that it's accurate, that it's securely stored and saved somewhere and backed up. The management of apps, making sure that the apps are always updated, that there is no bugs, all of those things. These are important because if any of these fail, the user packs up his bags and they go to something else, go to somewhere else. If there's a breach of your data, it's like, I don't trust these guys anymore, I'll go somewhere else. All of that, mostly the data side of it, oftentimes is stored in the cloud, like Extreme Cloud IQ. Data is stored in the cloud and you can have access into that data. But so is all the Gmail stored in the cloud and the Instagram posts stored in the cloud, which is, in this sense, the core. This is the core of the network. And on the other side, where the user is, that's the edge of the network. Now, in between those, where those two meet, you have the analytics, the reporting coming from one side, coming from the other side, from the users as they access this, what type of data, how much, how is the data being used, the apps, getting all of that management together, having a governance framework and infrastructure. These are important if you want to keep your most important stakeholder in your business on your side and not go into the competition. So those are the things. But What is your key driver in all of this? What is the key driver? So you have your user as the most important stakeholder, but the key driver in this is mobility, right? So consider what technologies may be needed to deliver things like the lowest total cost of ownership, TCO, the lowest total cost of ownership. Think about that, how that reflects when you're using a cloud service. How much does it cost? How much is the whole end-to-end piece going to cost? If you're a big player, these numbers make a lot of difference. What about manageability? How easy is it to manage a network? Now, mobility means that as a user, that user needs to have access to this anywhere and everywhere they go at the lowest cost of ownership. So if I'm using an application, I'm probably going to be using it on my phone a lot of the time. I need to have access to all of those services, all of that data through the apps, anywhere, from anywhere in the world. Same thing. The user nowadays is sitting at the edge of your network. Right. So the mobility that we spoke about moves on now, and let's talk about Wi-Fi. I know that we also have 4G and 5G, and those are great. Cellular data is great, but that's not our business. We're going to be focusing on wireless, and we're talking about a little bit here about Wi-Fi 6. Don't want to spend a lot of time in here, and the reason for that is we've already covered Wi-Fi in the second course. But take a screenshot of this, because and there's just one thing that I want to say over here. Over here, there's this point over here that says Wi-Fi 6E uses 6 gigahertz. So you'll see on our LinkedIn channels and stuff that we make a lot of noise about Wi-Fi 6E, right? 6E, the ability to have a completely clean Wi-Fi spectrum. 2.4, as you know, gigahertz is crowded. Everything talks on 2.4. Lots of noise. Think about a crowd. Think about a football stadium, and you're trying to call to your friend who's sitting just 20 people away from you. How difficult it is. Now, imagine that stadium is now during COVID times, and there's only, say, 5,000 people allowed in the stadium. It's a lot easier, right? Why? Because that spectrum is not so populated. There are much less people in there. So I can shout to him and he can hear me quite easily, or she can hear me quite easily. The 6 gigahertz, you're in a stadium, there's one person there. Big stadium, there's one person. You can sit on the other side. You could shout and they could hear it that easily. That's what Wi-Fi 6E is bringing to the party. Yes, we don't have all the devices yet. Yes, it's starting. But that's what it's offering, a blank slate on which you write your Wi-Fi 6 network. How fantastic is that? Again, if you want to, you can take a screenshot of this particular slide over here. I don't want to get into selling this. This is just some devices that Extreme Networks has in wireless devices that we have. This is some recommendations that we would make if you have and run a wireless network in 2022. It says 2020, 21, should be 2020, 22. We say, as a minimum, WPA2, okay, with PSK. Now, is that our recommended? No. That is our minimum. That is the minimum. You should not be using WPA. No. WPA2 is what the very minimum that you should use. Ideally, you should be using, if you're in enterprise, WPA3 enterprise with AES CCMP encryption. Use mixed mode, keep AES for maximum compatibility. That's what you should be using. And with Wi-Fi 6, 6E, there's going to be new levels of security. One of the fantastic things about Wi-Fi 6, Wi-Fi 6E is that there are going to be no more open networks. No more open networks. That's it. The end of open networks. Oh, that feature alone, I can't wait for that to come. Just sick and tired of open networks where just have so easy for people to spoof and steal data. Now, the preferred security environment. This is important that I'm bringing 802.1x. This is not the same as 802.ax, okay, or AC. This is not the same. This is not the same thing. The security environment 802.1x with PEEP, MS-CHAP, or EAP TLS. This is very, very important. So where would you see this mostly? Well, you should definitely see it in the enterprise. At home, maybe not, but enterprise, definitely. Other security enhancements, well, if you're Microsofty, machine authentication, Microsoft machine authentication, and of course, WIPS. So for those of you who don't know WIPS, WIPS stands for wireless intrusion. I'm writing terribly. Prevention. Oh, come on, Isaac, write properly. Systems. There we go. Wireless intrusion prevention systems. What you're trying to do with that is you're trying to prevent the rogue users who come into your network and bring their own wireless access point and plug it into the network, right? Because they want an extra access point and they're not getting good access in the company. And WIPS, this particular system, and we make probably the best WIPS in the business. There are others as well, of course, always. There are others as well, but we have these WIP systems that will look out for these things and will tell you and alert you as an administrator, hey, somebody on this floor has brought an unauthorized access point into the network, and they are creating a vulnerability, and they will alert you exactly to that point. So, these are systems that you should be, if budget allows you, have those systems. Very important. Isolate the Wi-Fi network behind the stateful firewall, even in the home, especially in the home, especially now during these times that we are having with a pandemic. Now, this is a little bit harsh maybe to say, but the key word over here is unknowingly, right? Remote workers unknowingly create more risk. If you have a low awareness of how user behavior exposes risk to company information, then you are in trouble, and you need to educate your people more. Okay, because it's a vulnerability. Kevin Mitnick, a very famous hacker, one of the first big, notorious hackers, he himself said that he's not that great as a hacker, as a pure hacker. But what he was very good at was social engineering. Turning up at a company and saying, I'm from the telco, we've had complaints of really bad, slow internet access in the area, and I'm here to check, to make sure that everybody in the building, who is going to say no? Who's going to say no, to slow internet access? Oh, yes, of course, internet's been slow. It's been like this for about a week. Yeah, absolutely. Yeah, that's what we see in our logs. No problem. There's the data cabinet. Please, help us, sort our issues out. That would really help us. And all of a sudden they're inside your network. Awareness of these things. It's estimated that around 85% of users bypass VPNs, right? If you have a VPN, if the company has given you a VPN, use it, especially if you're at places that are really open to risk. You know how many times I sat in lounges, airport lounges, and people, just open up and away they browse. It's like, hey, no problem. Anybody can browse. Anything is no issue at all. As much as airlines and all of these companies try and do, good things on the networks, How do you know if there isn't a wireless access point, a rogue access point that's been plugged in somewhere and is harvesting your information? Use your VPNs. They are simple to use. They're a piece of software on your computer. Double click it, creates a connection. Bam. At least if you're on an open network, at the very least, set up your VPN and use your VPN to access corporate data. But most times, remote workers create these risks because at home they have devices. They might have a wireless network at home. They've never changed the key, for the admin access to that wireless network. It's open, and suddenly they have devices at home, a corporate laptop, a corporate phone, whatever it is. It's on a network. The network is not even protected. You're creating a risk for your system administrator, right? During COVID, especially, companies wanted to look after the people. They wanted to make sure that employers were safe and secure and were healthy and were protected from all of those things. Companies needed to do that. But of course, they needed to also enable customers to be able to connect to their staff, to be able to do business. So we need to look after people, but we also need to continue our business. We also need to look after our customers. And to do all of that, we need technology, right? Technology and technologists and IT companies were suddenly put in situations where, wow, we now have to start dealing with something that we haven't dealt before. Think about this. I think I heard John Barger, one of our senior vice presidents, recently say he was talking to one of the it might have been the CTO of Extreme Networks, and he was saying, previously, all I had to do at Extreme was I had to secure a building that had 300 or 400 or 500 users. That's what I needed to do. That was my remit, provide secure access to these people. So now I have 3,000 offices, right? I have 3,000 people all over the world working from home, working from anywhere and everywhere, from a coffee shop to an airport, maybe not an airport lounge, but to wherever it takes them, next to the pool, using any network that they can get. Now I've got 3,000 times the problems and the headaches and how do I think about these things? Well, if that is a person like you, if you are in that position, then one thing that you can do is what we're going to be talking about over here. And that is, why don't you consider a way, an approach to managing remote workers by creating personas. In this example that I'm going to be working through, there are 3 personas, 3 types of operators. You'll often hear this in business. People say, when it comes to IT equipment, people say, well, that's a power user. So a power user, that persona needs to have, a really powerful laptop with, 400 gigs of RAM and blah, 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 blah. That user, that's office bound user. They're always in the office. They're managing calendars, managing, resources, rooms, etc., etc. They need computers. They need a big screen, though. Laptops are not good for them. They got a massive Outlook calendar. So we need, that type of worker needs a massive screen. And then you have, the Isaacs with the video equipment and all of that. Oh, they need, supercomputers, that type. Think about that. First one is always on, globally available. This is the type of persona that is, great for employees that work from home full time and with client-facing roles, right? They deal with clients. It's not like me. I don't deal with clients. I don't sell anything. But I do work from home. But I don't have that client-facing role. Seamless, always-on experience, enabling communication and collaboration with Zoom, Teams, etc. at LAN-like speeds. Okay, that's not quite me. Similar, I'm probably closest to that, but I don't fit that totally. But this is, try and identify the people in your organization that fit that, okay? They one type of persona. The second one is the on-demand persona, ideal for field-based employees, guys who are always out on the road, employees or those without a dedicated workspace. Salespeople, maybe not in this environment now, but I used to work and run the IT for a company that had something like 30 or 40 salespeople on the road selling packaging. And they spent their entire day out on the road selling, going from business to business, taking orders, making sales, phoning the orders through, high availability even when mobile. So they might have a laptop, for example, and they get to a customer, they plug onto the wireless network and they place the order. But other times it might be done from a tablet, from a remote, a mobile phone if needed. That's another type of remote worker. And then the last category is the BYOD, bring your own device. These are employees that do not need a VPN and may not have a company issue laptop, right? They might use their own stuff. Best for secure access to software as a service, things like Office 365, etc., and cloud applications with any device. So I don't need a computer for that. All I need to do is just do my expenses. As long as I have access into Concur in the cloud and I can do my expenses over there, that's fine. It doesn't really matter, what I need. So maybe when you're looking at these issues, consider creating these three personas and putting people into these these personas. And with that, you then end up looking at these things, the security and scalability. So for somebody who's always on globally available, what type of security, would they need? What about scalability? Manageability. What about total cost, of ownership? Think about all of those things and consider this. I can't give you homework now. We just don't have enough time for you to go and do all of this. But as a little exercise, maybe write down, take a screenshot of this, and then just make a note, if you will, on, I'm sorry about that. Just make a note of these three personas and think about in your organization, how would you place these the people within these personas to be able to do this: the security, the scalability, the manageability, reduced total cost of ownership, and high availability. Which ones of those personas, how would you structure the solution for those people? What would be most important for a always on globally available? Well, definitely high availability, right? If we go back here for this one here, right, definitely high availability. What does that mean? Do they need a fiber connection to the home? If they're customer facing, they probably do. Powerful machine, maybe a big monitor for those people, okay? What about reduced cost of ownership? Do you have a lot of these guys or a lot of those people? How would you reduce costs on those? Well, maybe we don't need to buy them laptops. We can buy them iPads and it will do the same job for a reduced cost. So try and do that as an exercise and see, where it takes you. If you haven't done this before, this will be a key exercise for you and will help you to start to understand how you manage these types of risks, especially for mobile users that need to access resources throughout the day all the time. Now what we'll do is we'll take a 10-minute break and then we'll come back and we'll finish off with the last two sessions. See you then. Okay, welcome back from the break. Let's jump into the next module. DC and cloud, not as in Washington, DC, no, not that DC. Data center and cloud. Let's talk about data center and cloud. So, as normal, I'll read this off the screen. What is a data center? It's all about the workload, high level anatomy of a data center or cloud technology silos, and then compute, storage, and the network. Okay, so what is a data center? A data center, because we hear this all the time. Sometimes when we talk about cloud, we will say, data warehouses. Google has these data warehouses. Essentially, it's the same thing. We're talking about the same thing, data centers. But essentially, it's a building, a dedicated space, perhaps within a building or a group of buildings, used to house computer systems and associated components. Okay. It's normally really, really large, especially for the big guys, for Amazon, Azure, and for Google. It's distributed, so you find these, in all countries or in many countries around the world, all interconnected. They generally are huge electricity behemoths. Some data centers, they use as much electricity as a small town does, and there are there's a lot of work being done to make these data centers green. Apple, of course, is another one, and they use a lot of renewable energy to offset their carbon footprint. But they have become an essential and necessary part of life. And today, I don't think there's anybody that's watching this particular episode that doesn't in some way touch a data center, a cloud data center, from the minute they wake up to the minute they go to sleep. From Netflix side of things, to social media side of things, to news, to Office 365, we touch these data centers every single day, and they are about five key technologies, right? Applications. These are the locations when you run these massive applications. And we've kind of spoken about that already. People are familiar with Office 365, which is, for mails running, Microsoft Exchange and stuff like that. We've spoken about a program that I use for expenses called Concur, which is owned by SAP. SAP, one of the world's largest distributors or vendors that own the code. So companies that provide solutions around SAP, a big financial system. And then you have, of course, the big databases, people like companies like Oracle, etc., that are so huge. Imagine governmental records, that type of information, huge scale, again, being held in data centers. So these applications live inside these data centers. Facebook is going to have a ton of them as well, and all these big social media platforms. The other key technology, of course, is computers, servers. In most cases, or in many cases, Facebook and companies like that, they don't even spend money on high-end servers. They just put in, white box servers, thousands, hundreds of thousands of them into data centers, and with lots and lots of storage on those as well. And there are rumors, I don't know if it's true, but there are rumors that say that Google, in their data centers, they have so many servers that if one goes down, they don't even bother, to run off and go and change it out. And if it goes down, right, it goes down. The system is so big that it will just continue. And then when they do their normal cycles, maintenance cycles, if they spot the server is down, oh, okay, they take it out and they replace it with another one. That's just because of the enormous size and the scalability of these of these data centers. Storage, right? Storage. So storage, if you sign up to, I think it's Microsoft OneDrive or something, Microsoft Office 365, I think they give you a terabyte of storage. Now, of course, we know that not everybody uses a terabyte of storage, but that's what they offer. Knowing full well that not everybody is going to use that much storage, especially for corporates, for large corporates. But it's there, a terabyte of storage available to you. Now, multiply that by the tremendous amount of customers that they have. And not just them. I mean, I'm using them just because they're an example that came to mind. But there are dozens, hundreds, of companies that do the same thing. Apple does the same thing. Adobe is another one where you can store all your photos in the Adobe cloud, and they offer 2 terabyte packages that you can have for your photos. So storage is a really essential mechanism for the way for these data centers to function, because you need big data. A lot of these companies use that big data to glean and to use artificial intelligence and to build clever models from looking at big data. They need to store this data. So that's obviously a fundamental component of a large data center. Data centers also require high performance networking gear, right? That's something that, I mean, think about if you have to connect hundreds of thousands of servers together. Those servers need to talk to a network. They need to be, probably fiber networks, 40 gigs, 100 gig, backbones, interconnect on these. So it needs a very, very high performance network on the back of all of this. And then, of course, they need management to manage this entire infrastructure. You can imagine what it must be like, to manage one of these things. It must be quite something to manage a data center. And of course, these guys are going to have 24/7, round the clock people on site, to support, to manage, and do whatever it is that they need to do. But the data center, especially a traditional data center or the older data centers, they can get bogged down, right? And nowadays, I mean, if you're sitting here, you're dead in the water. But they used to have a lot of slow, complex processes needed. A lot of slow, complex process that they used to have before to satisfy enterprise needs. If you think about it, so this slide is going to be building out, and you can see over here that you request VMs, and in the past, if you needed that could take, if you had your own data center, in your on premises, if you had that and you had a big IT team managing that, well, you need a number of VMs, right, to be spun up to help you to do whatever job it to do. It could take you easily 2 weeks, to get the approval. And I'm not joking about that. I mean, it's often said that you make a request for a DNS change in a corporate, and it takes you at least 2 weeks for that to happen. And when it comes back, they made a mistake and you need to send it again. So it'll take you a month to do that. But generally, if you had your own data center and you were controlling this, 2 weeks to get your VM spun up. Then you need to send in a request for a network. This is how I want the network to set up. And that could take another 4 days for that to happen. Then you need software to be installed on those VMs. So please, we need Windows Enterprise Server, we need Linux, and we need this version, we need that. We OpenStack, whatever it is, we need that. That could take another 4 days to provision and then get done and updated and all of those things. Then we need a database. Yeah, we need to spin up a database. This is what we need to do. This is give it another 8 days. Then, random troubleshooting to make sure it's all working nicely. Then give it another 6 days, for that. And you carry on and you carry on. And then you have random middle wheel troubleshooting. That might give you a problem when you start laying on top of the OS. Then, you need to develop an app. Once you've got all of this infrastructure, now you're going to develop on top of this infrastructure. Then once you've developed that, that'll take 40 days, to develop if you've got a good team. On top of that, user acceptance testing. All right, you've developed the app. Now, users need to test it, to check, and all of that. Put it into the quality assurance production pipeline, which is another 60 days. Scale it up, scale it down, set it all up, and 6 months later, you have a solution, right? And this is when we didn't have these massive data centers. This is how we did business. This is how we developed stuff. We developed this stuff all internally. 6 months later, if you were lucky, you had a platform on which to build. Right. But the data center is evolving, and we've gone. You might have heard this word agile, right? That's a very, very common phrase that you'll hear people talking about when they're talking about software development and data center and processes and things like that. So you will hear this term agility or agile all the time. So the data center is evolving from this old behemoth where it's like, hey, that's not my problem. All I do is I do this. I don't really care about that. That's somewhat, and there's kind of this opaque, curtain between different teams using separate tools, right? People all over the world developing. Everybody's using. Some are using Python. Some are using Java. Some are using whatever it is to develop for a particular platform. Well, the DevOps teams nowadays have shared responsibility, right? Because these platforms are sitting in the cloud. They supply all these teams. So you have shared responsibility, common tools. There's no opaque curtain between that. And that helps the development process. What about continuous delivery? In the past, there was this approach to developing content called the waterfall approach. Waterfall approach meant you upfront, you said exactly what app you wanted, how it needed to work, how it would test. You define all the requirements upfront. Then you give this off to the development teams, and a year later you come back and you have an application, which then has tons of bugs on it, for example. One of the common things about this. With Agile, your approach to this is you do it in smaller pieces. You have your requirements, and then you develop and release, develop and release, develop and release. So it's a lot smaller chunks. Think about it. If we were to try and eat a cake, if I were to say to you, oh, here's a big cake, you got to eat this whole cake, and you got to eat it in one go, I could probably fit that into your mouth, right? I could squeeze it and push it and shove it into your face, and eventually over time you could probably eat a cake. But if I sliced it up, right? If I sliced it up into small size pieces, and over a period of time, it would be a lot easier to eat a cake in small bits, in small bites, than trying to do the whole thing, in one long go. And that's what continuous delivery is it helps you reduce bugs because you're working on smaller components. It's easier to test smaller components and then get those out. And if you need to make changes, you can make changes very quickly. If the customer requirements change, for example, government regulation, that's a good use case or a good explanation. If that changes, you need to change very quickly and adapt your software to that. In the waterfall approach, you can't do anything until it's all finished, and then you have to start making these changes. So continuous delivery has been one of the big benefits of moving to these big data centers. And then microservices as well. We've again spoken about this concept of microservices. So instead of building an application all as one big intermesh of code, what you do is you build it in small little platforms, microservices. So in an application, if you build it as one large behemoth, if there's one service on there, for example, the authentication service that needs to scale up or down because you're having more and more users, in that model, you would need to add more firepower, more servers, more all of this just to handle one particular service. Whereas when you do it as a microservice, you can scale each service up or down. So if you need more power, more grunt to handle the authentication, you can just scale that up or down without having to buy extra hardware, new hardware for everything else. You can scale on a micro level. And that's a really huge benefit, which ultimately translates into a huge win financially. Now, this next slide over here is the where we're going to talk a little bit about the architecture. And again, David spoke about this previously. He alluded to this. But what I'm going to do here is we recorded in Reading, we used a light board and we recorded David teaching this part. It's about a 10 to 12 minute video. So let's bring in, yeah, Claire, yeah. Let's bring in the video and we'll watch it at this point in time, and I'll see you at the end of that.
Okay, so what I want to take you through now is really the anatomy of a classic three-tier architecture for the LAN. Now, these three-tier architectures have been around for years. They're well established, well understood. And if you go to any large campus, large enterprise, even a large branch of a large company, you're going to see the various infrastructure devices deployed using this classic three-tier architecture. Now, after this, I'm going to take you through a variation on the three-tier by collapsing one of the tiers, and we'll have a look at the classic collapsed backbone, a two-tier variation as used by mid-market or the smaller kind of enterprise environments for reasons that we'll explore later. Now, to start off with, ready prepared, I have the access layer and the clues in the name. The access layer is a series of boxes. These will be switches, typically switches, and these boxes are there to provide what? Access. So, access to wireless access points, access to users who are wired in, and any other kind of devices at the edge, at the access edge. Now, currently, I've got a very simple illustration here. I've just got 4 boxes, but in reality, I could have 400 of these boxes distributed throughout the enterprise campus. Now, we've got no connectivity as such, so let's start to build some connectivity by bringing in the next layer of this three-tier hierarchy. The next layer is sometimes referred to as the aggregation layer or the distribution layer. Now, aggregation, I'll just mark it up as AGG for our purposes here, otherwise I'm going to run out of space. The aggregation layer is there to aggregate traffic from the access layer, hence the name. So let's put some aggregation layer boxes in place. Now, these boxes tend to be higher performance boxes because they have to take the aggregate bandwidth from the access layer. The more access layer switches you have, typically the more powerful aggregation switches or boxes you're going to be using. Let's get some connectivity in place. Now, I'll have an uplink from the access to the aggregation. And for redundancy, I'll have another uplink. So we have this concept of dual uplinks. And I'll do this from each of my access layer devices, my access layer switches. Notice what I'm doing here. I'm building connectivity from the access to the aggregation, but I'm also considering redundancy. So there we are. Now, what have we got? We've got the access layer, we have the aggregation layer, but hold on a moment. We've also got something else that's appearing. These are referred to as building blocks. Building blocks are defined blocks of switches undertaking the job of access access to the users and user devices, and then boxes that provide aggregation of the uplink traffic. Now, I also mentioned that the aggregation layer is sometimes referred to as the distribution layer. So I'll just mark that as DIST''N. Why distribution? Well, think about it. If I want to go from this box here to this box here, my traffic travels up to the aggregation where it is distributed out to wherever it needs to go. In this case, another access layer switch. Maybe we have a user here on the first switch wanting to connect to a device or a user on the other switch. So the job of the aggregation layer in a typical 3-tier hierarchy is quite an important job. It typically reflects the policies of the business about what traffic should go to where, what communities of users of devices are allowed to share resources from other communities and other devices. And that means typically at the distribution, we're not just aggregating the bandwidth, but we're implementing some distribution policy. And I'm going to put a little circle with an X to denote intelligent processes, typically routing processes, to make those routing decisions how to distribute from one point of access to another point of access. So not only are these distribution layer devices having to be sized to accommodate all the traffic from the access layer, so they need to be pretty beefy, they also need to be pretty beefy in terms of their intelligence. They will typically be running routing protocols in order to be able to handle traffic from one point of access being routed by policy to another point of access. So far, so good. Now, I've got, 2 building blocks made up in this simple example just for switches. Remember, I could have 40 access layer switches. I could have 4,000. And I will typically organize these in a whole series of building blocks. As I say, we've just got 2 shown here, but I could have 20, I could have 200 building blocks for a very sizable campus deployment. Now, to link all of these building blocks together, yes, you've guessed it, we have the 3rd tier. Now, the 3rd tier is sometimes referred to as the core, but most commonly referred to as the backbone. And I've got to say, the main purpose of the core or the backbone is pedal to the metal. Generally, the core or the backbone is fairly dumb. Its purpose is to take large amounts of traffic from one building block and get it across to other building blocks based, again, on policy. Remember, we have the policy implemented at the distribution layer. So we can go from one point of access to another point of access, but equally have a policy to say, at that point of access, is it allowed out over, yes, the core. So I'm putting in 2 big core switches. Again, although they're not necessarily as smart as the distribution layer, they probably will have some kind of routing function as well. And again, for the purposes of redundancy, I link my distribution layer devices in a redundant topology to my core devices. And here we have 3-tier. Access to provide access. Uplinks to aggregation to provide some kind of distribution policy. And then out across the campus courtesy of the backbone or the core. Now from here, we could also route out to the outside world, namely the wide area network. So that's probably another good reason why these core devices provide some kind of routing service. Or they may simply route to an edge router that will then permit or deny traffic passing to the outside world. And that edge router is probably going to be a firewall. And looking at a typical large enterprise, it's going to be a serious piece of kit. What I hear you say, is there an alternative approach? Well, there is. And this is what I want to move on to next, namely the collapsed backbone. Okay, so here we are. As you can see, the diagram's missing a piece, a core piece, no less. What I'm showing you here is what is the classic two-tier architecture. And this is favoured by the smaller businesses, more mid-market businesses and enterprises, where maybe they haven't got quite so many of these building blocks. You know, in the 3-tier, we could have gone to many hundreds of building blocks, all connected to a common core of high performance and very expensive switching technology. What we're doing here, we haven't actually got rid of the core, but we've collapsed the core functionality into the aggregation or distribution layer. And the way we do this is quite simple. We just have a series of wires connecting each distribution layer device. We may also have some further interconnections between those distribution layer devices. Effectively, the backbone is still here. Clearly, it's still here, but the backbone is now effectively the cable interconnects between those aggregation or distribution layer switches. Why do this? Well, to be honest, it's likely to be cost. This is a lot cheaper deployment. Yes, you're compromising in terms of redundancy, possibly compromising in terms of performance. But then again, it's aimed at a different market. This is aimed at the mid-market or the smaller enterprise. The performance of that backbone is still all about getting traffic from one building block to another building block and potentially also out to the WAN. But that responsibility is now on these distribution layer devices. The distribution or aggregation layer devices are performing a dual role. Yes, aggregation and distribution, but also backbone functionality as well. The benefit? Cost. This is cheaper. And by the way, this is very common.
It's a really great explanation by David about the traditional and the more modern data center networking spine and leaf topology. Just want to bring in one slide over here, and this is what you see on the traditional. Performance is optimized for north-south. That's where the performance goal and objective is, north-south. And here, the performance on the optimized one, if you want to call it that, it's for the leaf topology. We're talking about east-west. That's where the optimization happens. Okay, so let's move on here a little bit now and talk to software-defined networking, SDN. As many of you know or might be aware, Extreme Networks recently purchased a company called Ipanema with a software-defined networking solution that we're going to be integrating into this. So what is software-defined networking? Okay, software-defined network. Well, what it is, it's a technology to separate the network control plane from the forwarding hardware, and this allows the data plane to be defined, if you want, by logically controlled or centralized controller or a set of controllers. Okay, so you are extracting, almost like hypervisor, you are extracting the control plane out of the system, and you're going to use an open flow technology, which is the southbound API. You're going to use that as the control protocol between those two. So software-defined networking is the architecture is under the Open Networking Foundation maintenance. We need three main components for software-defined networking. The first of those is open flow. Right, open flow. You can see here, if you ever go and do some searching, that's the logo, because there are quite a number of other companies and corporates and organizations or companies that use that term open flow, but that's the logo over there. So this is that southbound communication protocol that allows us to split the data plane from the outside, so that the control plane can be offloaded and maintained by a server. So on the top, the SDN starts with this this interface. It might, you want to call it maybe the glue that ties together SDN infrastructure with other user applications, where IT admin is able to initiate some actions, assign boundaries to them, and so on. Second part is Open Daylight, which is a controller, an SDN controller. And then the third part is OpenStack, okay, which is an orchestrator. OpenStack, people are quite familiar with OpenStack. Again, all of these terms, you can go and search them up. I'm not going to be spending a huge amount of time on these. We have spoken about them briefly before. In Extreme Solution, we've been able to purchase a solution that offers software-defined networking, but cloud-managed software-defined networking. And that kind of fits into this whole one single pane of glass, managing an entire infrastructure from the cloud solution. And you're going to hear a lot more of that. But what are the, if you want to call them, the value propositions? What are the value propositions for SD-WAN? Well, let's take a look at them. Here. Automation, optimization. Sorry, let me just call this up. Automation, optimization, and simplification. So those are the value propositions. And when you look at it in the architecture, well, programmability, central intelligence, abstraction, there's lots of benefits to using them. Take a screenshot for this and on this, and then you can go and do a little bit more research on these. I must say and confess, we are moving to release our SDN products, and all the information and all the learning is coming in. I don't know huge amount about software-defined networking. I don't know if you guys do. If you're familiar with software-defined networking and familiar with all the terminology and everything, just put it up in the YouTube chat over here. It would be interesting to know. But take a screenshot of this, because this is something that that you're going to hear more and more, not just from us, but from every other vendor on the planet, networking vendor on the planet. Okay, so let's take a 1.5 minute break at this point, and then we'll come up after that, and we are landing, right? We are coming to the end of this session. So of this course, we will land it. We might run a little bit over time today, but only by a few minutes. See you on the other side of this. Get up, stretch, do whatever you need to do just to refresh the blood. 30 minutes to go, 30 or more or less. Okay, so we've now covered everything that we wanted to cover regarding these large and resilient networks. And in the different modules that I've covered till date, there was at different times slides showing how would this module manifest in real world environments. And we used the esports environment in a number of examples. Esports now. Esports, we know that esports in the USA is growing really, really quickly, especially on university campuses, college campuses. But esports around the world has really become an absolutely massive gaming platform. They are saying that within a year or two we would be reaching approximately 1 billion online gamers. I mean, that is an enormous number of people playing online games, and it makes complete sense. I mean, today esports is generating huge amounts of prize money. It's filling stadiums. I mean, there's a real massive audience. So I want to cover a little bit about this, and as normal, the learning objectives, esports. The network is the field, right? As it is in football or soccer or whatever. The network in the case of esports is the field. So we'll talk a little bit about that, the gamer and the spectator, and then we'll look a little bit at designs and stuff like this. Extreme Networks happens to have a focus as well on esports. We're quite involved in esports because I think we also focus quite a bit on one of our major verticals, which is the education market, from K-12 all the way to higher education. In a survey that Extreme Networks did do, they said about 38% of schools have an esports competition facility. Now, again, I mentioned this as in the US. In the US, they have that, and they expect that to grow by over 25% year on year, or rather, 24 to 5% of those that don't have one are planning to have one. In the UK, I don't think we are there yet. I don't think we see esports as an integral part of a university or college, and maybe because of the way that universities in the US try and attract and retain students. So it's slightly different, but you can imagine this growing around the world in universities and colleges around the world. When I first heard about it in universities and colleges, I thought, students are going to spend all their time doing gaming instead of anything else. But not actually quite true. The statistics tell us something, a different story completely. And I've changed my mind in terms of the way I think about this. But the formula, really a successful formula for esports, will have these 5 components that we see on screen over here, right? There will be an issue about latency that needs to be certainly addressed. It's no good, in first player shooter games or whatever, you fire a shot and whatever you were shooting at is no longer there when you fire it because of latencies and jitter and stuff like that. So latencies, a minimal latency is really important to have a successful esports franchise, if you want to call it that. Visibility, of course, to the players, but to the spectators. It's really important. I was really amazed with my son, with my youngest son. He enjoys computer games, but I actually think he enjoys watching other people play computer games more than him playing it himself. It's quite astounding that that genre has become such a massive industry, right? Just watching other people playing games. So visibility of what they're playing is really important. If no one else can see it, well, it's not really that popular. Certainly, of course, when you start, it's quite different. But this is one of the success formulas that you have. The other one is security, right? That's important, both from the game developer side, the networking side, the player side. No one wants to have bad game experiences where they are hacked while a game is going on, while a show is going on, while a network event, gaming event, esports event is taking place in the stadium. So you've got to get that side of it right. Of course, the cloud and the ISP, the cloud technology that you're using, for example, using CDNs, and I think we'll cover this a little bit later. That's also important. Games nowadays are absolutely huge. 100 gig is not unusual for a game or even a game update nowadays. And pulling that down onto your local machine is an issue that affects gamers. So that is an important consideration, as is your ISP. And then, of course, tools to help you in the network management process. So a real 1, 2, 3, 4, 5 components that are absolutely necessary for you to create a successful esports environment, be it in a school, in a university, college, wherever it might be. Now, statistics tell us, and gaming companies say, at the minimum, you need about 1 to 2 megs download speed. It's going to be sufficient to play most online games, right? Most online games. Now, bearing in mind that most games are installed locally, but then you're competing with others, so you really need 1 to 2 megs download speed. But more important than that is the issue of latency. Latency really is the key. No one likes to have a lag between when you do something and when it actually happens. That is not good. That doesn't provide for a good experience. So even if you have a very fast bandwidth or a lot of bandwidth available for you, in terms of online gaming, it's not that's important. It's really the lag, the latency that is important. And latency is defined as, I'll read it. Latency is defined as the average time it takes a network packet to travel from you to a server and back. Okay, from the average time it takes from you to the server and back. That is what we talk about what we mean when we say latency. We see it, when we're loading a web page, for example, and there's latency on it, or games, struggling to keep up because of latency. Well, that is the one thing. The other term that you're going to be hearing in the esports arena or in network gaming arena is the IND. Okay, interpolation delay. Interpolation delay, and this is something that you might see in the stats, displays of some of the game, and this is that small buffer of time between when your client gets information from the server and when it shows up in the game. So when it shows up, when you get it from the server and when it actually shows up in the game, and this is normally around 50 milliseconds, 60 milliseconds is kind of the norm. Round trip time, another terminology, another word that you're going to hear, round trip time, RTT. This is the duration, again in milliseconds, measured from when a browser sends a request to a server and when it gets the response back from the server. So these are kind of terms that you're going to be using or listening or being aware of, because these affect gaming. Now, in terms of protocols, most gaming chat or non-critical game lobbies, etc., is all done using TCP, but the games themselves are generally most often done using UDP. Now, in terms of network performance, if you can't measure it, if you can't see it, you can't manage it, right? It's always the case. How do you know what is good, what is bad? How do you know where your network is struggling if you can't see it or measure it? This doesn't only apply to this. If you want to see the success of anything, if you want to see improvement in anything, from losing weight to your fitness, if you don't measure it, you can't change it. If you don't see it, you can't change it. So it's important to measure. And so the question then becomes, how do network people, how do administrative people, administrators, how do they measure network performance? That's an important consideration. One of the ways that you can measure it, and this is like a really high-end way to do it, okay? So although we're talking about networking in esports at the moment, if I can just step away for a moment and bring it back and say to the enterprise game, well, how do you measure this network performance? Because we know that we can measure, for example, what's happening on a switch. We know that we can measure what's happening on an AP. It's easy. If you got Extreme Cloud IQ, you get all of those measurements. How hard an access point is being hammered, etc., etc. But if you really want to understand what's going on your network, where the bottlenecks are, where the issues are that are causing latencies and things like that, that's a little bit further deep into a network. And one of the ways that at extreme, the ways that we do it is we have an architecture on some of our switches. We have an architecture called the insight architecture. And think of it like this. If your switch is insight architecture capable, then what it means is in your switch, you actually have the space for a VM. And onto that VM, you can install applications. Applications, for example, like Perfsona. Perfsona, if you haven't heard about it, is a project, an open source project that mostly used within the scientific research, university, colleges community. And what they do is they put probes, within their networks as they connect to the outside world. And they have thousands of these distributed around the world. If you're a university or college student watching, you should check and see if they have this at your university. And then those probes will then provide real-time network information, right, to whoever research organization is wanting to figure out what is going on the networks, why are networks slow, or where's the bottlenecks. And this is for all over the world. But you can download that software. It's for free, and you can install it and run it on your own network. But you can actually, on these particular switches, I mean, if you want to take a screenshot, you can actually run it inside those switches. So you have a real-time overview of what's happening on your network and see exactly where the delays are, where the lag, what is causing those lags, and then address those issues. I thought that is a really fantastic method. There's other things. There's other tools, for example, that you can use. You can use tools such as MTR, MyTraceRoute, and those are open source tools again that you can use to be able to check and see the performance as you go along on these routes. You can do a search on Wikipedia for MyTraceRoute, and then you can go and download the code for Windows or for Mac or for Linux. Mostly a Linux tool, but gives you a lot of information. So those are the thing. The latencies are things that we need to deal with and reduce as much as possible. But you also need to, if you're working in this environment, you also need to secure the digital, these ecosystems, right? And for that, you use something that we call network access control. network access control, often abbreviated NAC, network access control. And this is a suite of tools that give your network access control, that control access to your network. Now, we've spoken about previously, at the beginning of this course, at the beginning of this episode, we spoke about things like WIPs and how important it is to have WIPs, for example, for wireless networks. But NAC is broader than just wireless. It's for the entire network, and it deals with things like onboarding and authentication. So think about esports in your school, in your college. What you need to provide those 5 factors, those 5 success factors. So onboarding and authentication, only the people who can play are allowed to play, or should be playing, are allowed to be playing, right? Device management, managing of devices, network access control. Only specific people or allowed people can get access to a network. Posture enforcement, device profiling, like this device, this Windows machine is not allowed to join the network until it's got the latest service pack or the latest, updates to the antivirus. Once it's got those, I will allow it, to be able to join my network. IoT management, all of those things fall within this. All of those factors fall within this NAC suite of tools that can be used to protect an environment like an esports environment. I mentioned something about CDNs. CDNs are also a really important component of esports. Now, CDNs are really there. They are distributed POPs, point of presence, around the world. So if you think about what you don't want when you have a major Activision or one of these big sports manufacturers, software houses that make games, when they release games, what you really don't want is you don't want the whole world to go to one location, even if it's got 10 or 20 servers on it, to go and get these updates or download the games. I mean, these games can be really large, 100 gigs, maybe even more. And even sometimes they release updates on the day that they release the game, which makes it even worse. And you have millions of people wanting to play the game and download it, hammering this. If you just use another example, think about Apple updates, right? When Apple publishes a new iOS update, there are, 1 billion devices in the world that are probably capable of downloading. How is that managed? You cannot have a billion people going to a bunch of servers, so you use CDNs. It's distributed, that you put those updates onto points of presence, meaning servers in locations distributed all over the world, close to a consumer. And when you make a request to that to the app on iOS, for example, to click on it and say update, it will verify where you're coming from, and it'll look at your IP address and say, this person is coming from the UK. Actually, they're in Cambridge. Guess what? The best location for them to go to get this update is London. I'll send them to London. And you'll go to London and get a pop. Somebody maybe in Scotland might go up to Edinburgh to go and get that particular update. So CDNs are an integral part of esports, of downloading those games, getting those games to the users with massive amounts of size and updates and things like that, but making the process really easy because the content is distributed around the world. Here, I don't want to spend a lot of time. Again, if you want to take a screenshot, please go ahead and take a screenshot. Here we're talking about, different levels, of esports. You don't have to have the most expensive and the best of everything if you want to have a esports network. So this is just talking about your network. But there you have, we've split it up into four different layers. If it's a club entry, club performance, competitor, and pro, these are the types of networking infrastructure that you would need to have to be able to run an esports franchise and run it quite successfully. Then finally, some more, esports packages. What these things offer you: speed, security, simplicity. Fantastic, right? Really, really easy. And then let's land with the pillars of the esports arena: design, computing, and infrastructure. Design, right? I mean, I wish I had these when I was at school, at high school. But of course, that didn't even exist. But how funky would it be to have systems like this at your schools or your colleges, right? Where you can have 10, 20 gamers maybe participating, playing against each other, playing against other universities. So obviously you need the infrastructure, the design of the place. You obviously need the computing power, the machinery to be able to handle really high performance graphics, very low latency, fiber optic network. Those things are important, right? The lighting, the mood, a shoutcaster, commenting on the games. You need all of those things to really create an environment. And because of that, you can see how the popularity is in Korea. They have them. They have these as well. They have just thousands and thousands of these. Not so much at universities, but what we call internet cafes. They got gaming cafes as well. So what about mobile? Because that's the next frontier, right? For so many years, gamers have been on, Xboxes and PlayStations and the Wii's and things like that, and those have been the driving forces behind big, powerful gaming. But mobile devices are becoming more and more powerful, and they have larger screens, much more, processing power. If you think about the latest iPads from Apple with iPad Pros with M1 processors on them, I mean that's outdoing the amount of power that you get in most laptops nowadays. End-to-end screens, fantastic. This is becoming more and more of a big platform for gamers around the world. Play anywhere from any device. So this is growing as well. But if you're interested, if you're in the UK, for example, you can go and check out, esports. There's a body that oversees esports, and you can even go and do, I think it's in Edinburgh, there's a university that you can even go and do a degree in esports management, which is, end-to-end esports, and make that a career. And you can have, career in marketing, gaming, networking, all of those components that make a successful career, something that you will thoroughly enjoy. In terms of education, I really like this. I really like this a lot, because this is one of those things that when I initially heard about esports in colleges, like, oh, this is a total waste of time. But if you think about this, right, today we have a lot more respect for people who are not physically able, who have physical disabilities, maybe people who just don't enjoy sport as much as others do. They don't enjoy running around on the fields, even though it's healthy and all of that. It's not their thing. But esports is a leveler, right? Not everybody is going to be a quarterback in the States. Not everybody is going to be a Cristiano Ronaldo in scoring goals. I mean, we see these teams, playing, and we enjoy them. But how many people that play football actually end up right up at the top? For many reasons, sports, for injuries, all sorts of stuff, they don't always get to the top. But esports is a leveler, because you see, it doesn't matter if you built like a brick, if you're a god, built like a Greek god, and people love you at the university, whatever it is. If you don't have that physique, it doesn't matter in esports. Esports, you don't need that. You don't need to be, super fit. You don't have to be, somebody who's got a physique built for the Olympics. Esports levels all of that, and it's not your ability to run faster than anybody else that makes you great. It's your ability to react faster, to play. And so it gives those who are not sports elite a way to become heroes in an organization, because they might not be able to run around fields and run a 10-second, 100 meters, but they might be absolutely fantastic on gaming. So gaming and esports, I think, is an incredible leveler. It gives everybody in a school, in a college, no matter if they feel like an outcast, or no matter if they, people don't think that they look great, or you know how people are, right? It means that if they can game from behind a screen, that's what counts. And that's where our heroes are. That's, I think, one of the most important things about esports. Lots of other things on here. Again, you can read this. Get into esports. Create a career for yourself. If you don't know, if you're a little bit lost, what you're going to do after watching all of these courses, you don't know, what you're going to do, think about esports. If you're young and that, this is a new thing, especially in Europe, especially in the UK. This is a new opportunity. Open up grab it with both hands, because there's so much in esports that you can hold on to. Video production, audio production, shoutcasting, playing, setting up networks, wireless, securing. There's so many careers that are waiting in the esports arena, and they're waiting for people like you. Hey, thank you so much for watching. It's been a privilege for me to be here and to teach and go through this content. I really hope you've enjoyed learning, enjoyed growing, enjoyed advancing your career. Look at that URL, Claire. Just put it up again. If you have stories to tell, please email us on this address up on screen. Tell us about your stories. You might even get a t-shirt. Who knows, an Extreme Academy t-shirt. Thank you once again. Thank you to Rowan. Thank you to Claire, to Bethany, the people behind, that do the development of the curriculum. Other people that do and work on the video production stuff for us. Thank you so much. We really appreciate it. And hey, it's been a privilege. Thank you. Cheers. Oh, I forgot to say. I almost forgot to say. There is an exam, and after this, Claire is going to, there's a segment that Claire's coming on, I think a pre-recorded segment. She's going to tell you all about the exam, about how you get to do it, where it is, when you can take it. She'll give you all that information. But remember, if you've watched this course, episode 1 to episode 6, if you've watched all of this, don't stop here. Go beyond. Go and write that exam, right? Don't be like that guy who swims the ocean. He crosses the ocean, and as he sees the beach, he gives up. No, don't die. Don't die before you get to the beach. Go and do that exam. You finish this course, you know your stuff. The exam's not going to be easy, but go and get that XIQ. And then when you do that and you pass it, then go on to LinkedIn and just put extreme at the @ Extreme Networks Training, or my name, or Claire's name, or Rowan's name, and we will be on there and we will be congratulating you. Fantastic. Well done. Claire, up to you. Cheers.
Hi everyone, and congratulations again on making it to the exam part of course 4, network design. I say it every time. I'm so chuffed with everyone that's got this far in our academy courses. Course 4 now, so if you've done all the other 3 courses before this point, that's awesome. So now we're just going to quickly run through how you can get access to this network design exam and get your certification. Now, I might be repeating myself again. If you've done the other courses with us before, you'll know the drill, but I just need to go through a few details for you and for everyone else that might be new to us. So you just need to take yourself to our Academy website. Now, we're going to share all the details. If not, it's either side of me. We will share down below in the comments, so don't worry if you miss anything. So you are taking yourself to academy.extremenetworks.com. Now from our homepage, if you direct yourself to the top corner, you'll see a login drop down, and if you select the support portal, here's where you'll be able to log yourself in. Now again, it's good to mention that if you are new to us, here is where you need to create yourself an Extreme Academy portal account. And if you're not new to us, you should be able to use your credentials that you have signed up with before, and you can do it here. Now, just jumping back to if you are new to us here on your Academy journey, the registration process is very simple. Once you select that you need to create a new account with us, you fill in the details and click next. Now, once you've completed your registration details, next all will happen is that you should receive a registration confirmation email almost instantly. Remember to check your spam or junk folders because it might drop into there. From your email, it will have a hyperlink that says an Extreme login page. So click here and this will take you through to the Extreme Dojo where you can access the exam. It'll ask you to create a new password to do this, and then you'll be able to get straight in. Now, once you're into the dojo, here's what you need. Please use this QR code or the hyperlink that is showing around me. Again, we will share everything in the comments section so you won't miss out. But this is the QR code to take you through to the exam. Now, once you hit the exam, please double check the requirements as usual for our Academy courses. It's about 40 questions, you'll have 60 minutes to do it, and you do get 2 attempts. So, naturally we would hope you would smash it first time, but if you don't, you do get a second attempt. And if you do need further attempts, then you can drop us an email, or I think there should be instructions on the dojo of how you request that. And that's it. Once you passed, you have maybe got your 4th badge now in network design, which is so cool. And I'm super chuffed with everyone for getting this far, as always. So that's it from me. Again, you can always come back to this recording and check out the exam process. We'll share everything in the comments. And remember to join us on LinkedIn. We have our Discord server, our LinkedIn community. Everyone's there to help you throughout your Academy journey. So I look forward to seeing you in those platforms, and good luck with the exam.
Thanks, Claire. Thanks, Isaac. Well, we're coming to the end. This is the end of the course, and I'm just going to wrap up, just say goodbye, do a few thank yous. Firstly, thank you to you. Thanks for joining us live. We really enjoy doing these live streams. We love interacting with you. Thanks for joining on and watching on demand as well. If you watch these episodes on demand, I just want to finish with something. I want to remind you about what you've learned about, and I'm going to do that by just reviewing the learning objective. And I'm going to read it out. I've got a screen next to me, so there's a couple of paragraphs here. I'm just going to read it out to you. So you've been learning about building scalable and mission critical networks. So the learning objective was to gain an understanding of why large scale networks are needed worldwide and how the design basics are implemented. You took a deeper look into security and resilience of large networks and what management tools can be used to understand their data. And using real world use cases, you gained an understanding of why large-scale network design is so important. I wanted to read that out just as a reminder about what you've been learning about. There's been loads covered. Isaac, and the team, they've covered loads throughout this course. Some really complicated stuff, but now you have it. You've got a knowledge of what it takes to build scalable and mission critical networks. Now, I just read that from the website. It's also on the PDF relating to this course. And my call to action to you is go and copy that. Go and copy that. Put it somewhere in your CV or your resume, in your or the notes that go with it. And when you go for your next interview, either to advance in your current company, or if you're trying to get a job, just use some of that language during the interview and let people know that that's what you know now. And if you don't have experience of working with large networks, it's okay. You can't get that unless you're in a job. But what you can demonstrate to the person who's interviewing you is that you've now got an understanding of what it takes to do that job. And that's going to really impress the person who's interviewing you. And remember, take the certification exam. Like Isaac said, don't go through the whole journey and then don't take the certification exam. He's saying don't go through the whole journey and then don't finish. So take the exam, have as many goes as you need to take it. If you fail it, don't worry. It will, you get another chance, and then it will reset automatically, and you can have another go later on. So just get that badge, put it on your CV, because then that's proof that you have this knowledge and you understand what it takes to manage these big networks. And that's how you advance your career. And that's what this has all been all about. This is what Extreme Academy is all about. We're doing this because we want to help you advance your career. Okay, right. I'm going to finish now. So thank you to Claire. Thank you to Isaac. Thanks for everybody on the team that's been involved. We're going to miss you. We really enjoy doing these live streams. We miss the chat and the laughs we have in the chat window. We will be back. Extreme Academy continues. There's a few things to call out. If you want to stay in touch, the best way to do that is through Discord. So join Discord if you're not there already. Jump on Discord. I think the information's been shared quite a lot of times, and on there you'll find people that can help you. They can help you develop your knowledge. You can stay part of the Extreme Academy community. You can ask Isaac questions. He's on Discord very often, and you can interact with Isaac directly. Follow us on LinkedIn. Claire, if you can just put up the LinkedIn address one more time. Follow us on LinkedIn. That's where we're going to be releasing information about what's coming next. Isaac and the team, are they going to be working on some other productions next? So they're going to be on the Welcome series, so look out for those. If you've seen the previous Welcome series, you'll know what it is. It's about welcoming people to areas of the Extreme product family. So that's coming up next for us. That's what we're working on. And then soon after that, we're getting into a really exciting project, which will be part of Extreme Academy. And we're going to be looking at Stadium Wi-Fi. And if you've been watching the news about Extreme Networks, you'll know that we've announced some big new relationships and extension of existing relationships with some of the biggest sports franchises in the world. And we're going to be going behind the scenes. We're going to be showing you what it takes to make Wi-Fi work in a high density environment like a stadium. That's really cool, and something that's really going to differentiate you when you learn how to do that. So that's coming up later in the year, but we'll keep you in touch with everything if you're following us on LinkedIn. Okay, that's it. We're going now. I wish you every success in wherever your career takes you, and we'll miss you. So keep in touch, and we'll see you on the next program from Extreme Networks here on YouTube. Thanks a lot. Bye.